Today I would like to present Class A power amplifier. What is Class A power amplifier? It's an amplifier conducted during all the full cycle, or it also has a conducting angle of 360 degrees. Is known as Class A power amplifier. For the characteristics, first of all, it's low efficiency due to being all the time around vicinity of 25% to 50%. And it's also no turn-on time or charge storage problems. It's also quite stable, high linearity, high heat output during operation, low signal distortion levels, simple design, and the last one is the device is always conducting due to amplifying element bias.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Okay guys, meet with me. I'm Azizul Muhammad Zaki bin Osman. Today I'm going to talk about Class B power amplifier. What is Class B power amplifier? Class B power amplifier which is amplified at the cut-off point. The Q point is at the x-axis. When biasing at the Q point, it will form the half input cycle. As you can see here, this is half. And when the graph have the below this point, it will be full. So as you can see here, this is half cycle. So Class B power amplifier will perform the half cycle of input. Next, how we are going to improve the half cycle? By using the push-pull circuit. In push-pull circuit, we have NPN and PNP, which means it will perform the full cycle of graph. What we have in the circuit is the positive and negative transistor. Next, we are going to the characteristic for this Class B power amplifier. First, the characteristic is this Class B power amplifier have two transistors, which is NPN and PNP. And second, this Class B amplifier is stable and reliable. The Class B power amplifier also have the highest efficiency, which is 75% to 78%. Class B power amplifier also needed 0.7 voltage to start up. When combining two half cycles to perform one full cycle, it will cause a little bit problem, which is the crossover. What is crossover? The key point is switching. When the circuit is switching between device with driving a load, most often when the device are matches. How the graph of the crossover? Let's do this. The graph will happen when the input, and it will cause a crossover here, which means this is the crossover. The gap between this and this. So that's all from me. I hope you all understand and score to your exam.
Hi, my name is Aini Nabila. Today I want to talk about Class AB power amplifier. Class AB power amplifier is a mix of Class A and Class B power amplifier. Like Class B, it also uses two conducting elements, that is transistor, but both run at the same time. This eliminates the dead zone from negative 0.7 volt to positive 0.7 volt, seen in the Class B power amplifier. But in this case, while each transistor conduct for more than a half cycle, they conduct less than a full cycle completely. This is a conduction angle is somewhere around 180 degrees, commonly shown as 270 degrees in some cases, and this is the diagram. For the characteristic for Class AB power amplifier, it used two transistors that work together, combine Class A and Class B characteristic, and fairly efficient at around 50 to 60 60%. The efficiency for Class AB power amplifier is the best. It's the best than Class A and Class B because it has no crossover distortion.
Okay, hello. My name is EDAC Assignment. Okay, I will describe about Class C power amplifier. So, for Class C power amplifier is something of an oddity compared to Class A, B, and C. It also has the lowest operating cycle and linearity. Next, it stays on for less than half on input cycle. It have also conducting angle of 90 degrees. Okay, for Class C, it also result in high efficiency, but also cause high distortion in the output signal. So Class C amplifier are usually not used as audio amplifier. We use Class A power amplifier for audio amplifier. Okay, next we go for the characteristic of Class C power amplifier. The first characteristic is it is the least linear power. It is the least linear among power amplifier. It also has a high efficiency, around 80 to 90%. It has high output distortion compared to other power amplifier. And last, it has two operating modes, which is tuned and untuned.
Ain. Actually, I got a problem. How are you going to solve this? This task one.
Follow me. I will show the solution.
Alright.
Okay. Now I will show you the calculation for task 1. Okay. First one is we have to calculate for IBQ. Okay. IBQ, the formula is VCC minus VBE, then you divide to RB. So VCC is 18, VBE is 0.7, and for RB 2K. Then we get 8.65 milliampere. Okay, next we calculate the ICQ. For ICQ, beta we multiple to IB. Okay, 80 is the beta, and then 8.65 milli we got from IBQ. So we got 0.692 ampere. Okay, the third one we calculate the VCEQ. Okay, for VCEQ, the formula is VCC minus ICQ RC. Okay, for VCC is 18, and then we minus with the 0.692 and multiply to 30. Then we got 2.76. Okay. Next is output power. For output power, it is IC equal to beta IB, and the power output is the formula is I2 multiple C P and RC divide to 2. Okay. 0.3 to the power of 2. Divide 2 and then you multiply with 30. Then you got 1.35 watt. Okay. Then you calculate for the input power. For the input power, VCC multiple to ICQ. We multiply 18, then multiply 0.692. We got 12.456 watt. Okay. The last one we calculate the efficiency. For the efficiency, power output, if divide with the power input, then multiple to 100%. Okay, we got 10%. So Azizul, what class do you think this for this circuit?
Based on the explanation before, I thought it was Class A, right? Am I right?
Yes, correct. It is a Class A power amplifier.
Oh, okay.
What are you doing, Nash?
Oh, actually, I'm solving task 2.
I see.
Do you want me to teach you?
Yeah, sure.
Okay. Okay, for the task 2, beta that given is 100. So, first of all, we get the value of VB. Okay, VB, the formula is R2 divided by R2 plus R1 multiplied by VCC. So we get 0.7 volt. Okay. Next, KVL. Okay, VE, the formula is VB minus VBE. So we get 0. For IE, the formula is VE multiplied by RE. So we get also 0. So ICQ, IE, IC is equal to 0. Okay, the third step is VC. The formula is VCC minus ICRC. So we get 20. For VCEQ, VC minus VE, we get 20 volt. Okay, for the power output AC, we get, the formula is 0.5 multiplied by 20 square root over RC parallel to RL. So we get 75.8 milliwatt. Okay, for the power input is equal to 0. Okay, for efficiency, power output AC divided by power input DC multiplied by 100%. So we get 76%. So the power amplifier class for 76% is class C.
I think you are wrong.
Oh?
If I'm not mistaken, 76% of efficiency is class B.
Oh yeah, sorry, I'm wrong. You're right.
Okay.